and welcome to 6G World. I'm here with Stephen Douglas, Spirent's Head of Market Strategy and a member of UK 5G's Security Working Group. The company Spirent overall is responsible for testing and assurance of network security and positioning, so it tends to have one eye on what's coming down the road. Now, Stephen's been heading up the development of Spirent's 5G strategy for quite a while now, and it's great to be able to explore what comes next with him. Hi, Stephen. Thanks for coming in.
Hi, Alex. Great to be here today.
Yeah. Now, Stephen, I know it's early days, but do you see a consensus forming at all around what 6G might be or do yet in terms of the conversations that you've had? And so, you know, what Spirent's strategy is going to have to be as we sort of look towards the next few years?
Yeah, it's an interesting area, Alex. I would say, I mean, there's the do and the be of what it's going to be. I mean, the do side of it is, you know, I'm not convinced there is as much as a consensus on the do side. I think we're seeing quite a mixture of use cases, some which are ranging from sort of enhancements to what 5G potentially was meant to be delivering, right through to probably really truly generational use cases around sort of more holographic tactile communication, localization and sensing. Where I think we're probably seeing more consensus is around the B side of it, maybe around the architectural areas that are now being sort of discussed. I think definitely we're seeing consensus around it's going to be some form of network of networks, primarily, you know, some light or tight or loose integration or federation of various networks, you know, to create an unparalleled coverage landscape. And that's interesting because I think we're hearing more and more some of the stakeholders talk about what we call the 3 C's, this convergence, coverage, and consistency. And although that doesn't sound very sexy compared to, say, maybe the use cases, it's actually probably maybe more game changing because, you know, with true connectivity convergence, you could create a seamless and near ubiquitous coverage, reducing sort of barriers to innovation, creating, you know, connectivity equality. And the consistency side of it is probably the other key takeaway. You know, if you can create consistent connectivity, which is probably more important than the sporadic sort of peaks and troughs of speeds and coverage which we have today, then I actually think that is possibly going to be quite game changing. And of course, Alex, under the hood of that, I mean, there's a lot of moving parts which are being looked at today. There's new research we're seeing in things, you know, around the terahertz radio frequencies. We're seeing quite a lot of focus on the use of cell-free and device-to-device types of architectures. Some of this stuff's already coming into the 5G landscape. You know, you're seeing evolutions of Sidelink, which was originally for vehicle communications, now is becoming part of mesh network architectures. But I think the other consensus, if I was going to, you know, look at it at the highest level, is probably around AI machine learning. I think that's probably the other key takeaway we're seeing at the moment, where AI machine learning is now being looked at every layer of probably the future 6G architecture. So it's not just about the operations and maybe management of the network, but really being built right into the lower level radio data layer, link layers as well. You know, focusing things on like shared spectrum management, interference management, spectral efficiency. And I think that's probably going to be a big part of it. I think what that sort of, you know, leads to, Alex, in terms of what it means to Spirent as a business, you know, obviously, as you said, you know, test, security assurance are a big part of our business. And I think it's really twofold. I think networks of networks, which is really about also open networking, means that we're going to see more suppliers, more software, more cloudification, and obviously interoperability. And that complexity with the volume, the velocity of releases, vendors, combined with the need to safely and performantly interoperate means that sort of test and assurance has to evolve to become more of that automated sort of life cycle process where you're going from continuous testing to continuous monitoring and back and forth seamlessly across not only the life cycle processes, but all the operational divisions or stakeholders that are now part of this network of networks. And I think the other probably takeaway for us is going to be around AI and machine learning. And I mean, I think there's 2 pathways here. One is that obviously we're going to use AI machine learning, you know, combined with automation as part of, you know, how to create the testing, make it more agile, be more efficient. But I think the other side of it is what's test's role in the governance of AI and machine learning. And I think that's a big role for us to play there. How do you make sure the AI is unbiased? How do you make sure the recommendations, the decisions that it's causing on the network can be trusted, are delivering on what they're meant to be. And I think we're already starting to think about that today, because some of obviously these AI machine learning capabilities are starting to come into the sort of the 5G thinking.
Yeah, absolutely. I mean, I get the impression then that the sort of very notion of what assurance might be is going to have to change quite radically. And if we're moving towards more of this kind of network of networks scenario, where I imagine that there are going to be different types of capabilities inherent within the different networks, depending on who's spent what on them, then actually being able to take an assurance look across the whole vista of that is going to be a very different prospect to what you get today, for example, within, let's say, Vodafone's network or something like that. I mean, how do you even begin to address that kind of change?
Yeah, I think it really comes down to a few areas. I mean, one of them, Alex, I think is it's not just about visibility; it's about demarcation. I think that's the key word. It's how do you isolate and demark where probably across these networks of networks, and even within the network, which is in essence still multiple domains, an issue or a lack of adherence to, say, a performance criteria is, and I think that's going to become critical, more and more critical, because you've got an opportunity with network of networks not only to firstly identify, because maybe to fix it, but to potentially route around it, bypass it, to make another intelligent, use another part of another network to give you that connectivity. This is sort of the idea where cell-free networks are looking at the moment. But it all harks back to how do you have that sort of visibility, and how do you have that in a proactive way across these disparate networks. So I think that's one part of it. I think the secondary part of it really starts to focus in on, I think primarily more about how the networks relate to each other in terms of their own SLA agreements. Because in essence, if we're going to have networks nearly have to be like open APIs going in the future. We need to have, this network's going to subscribe to that network, and that network's going to guarantee a certain criteria or set of services or a certain set of SLAs. And if it doesn't meet those, then that's an issue there. But if it does meet them, then I'm happy to work with that network. And I don't really care how that network's designed, architected, built, or works, as long as it delivers on those SLAs. And I think we're starting to see this mind shift change, and the whole open networking sort of movement is sort of driving that concept, because in reality, this is how IT environments are designed today. You're subscribing through an open API to a service and to a quality of service, and I think we're starting to see that concept coming more into the network side of it. I think the third area, though, probably the last area, is back to what I mentioned earlier on, is the governance side of it, because the challenge is a little bit going to be, most of the networks we manage today, in essence, are managed by humans. They're designed with specific criteria, how they'll perform, how they'll behave. More and more, we're going to see the decision-making of the adoption of the network when it decides to potentially use another network, or it self-configures or self-changes itself, will be left to the sort of the AI machine learning. And I think a big part of the assurance process here is going to be, how do we actually, first of all, help the AI make the right decisions by feeding it and seeding it with relevant data, but also then how do we also at the end validate the decisions are actually the most optimal decisions? Because I mean, this is one of the challenges we're already seeing in discussions with private networks today, is that when we design a private network, you could make a decision based on security, and security maybe means two different things. In the macro traditional consumer networks, it really does mean sort of the premise that our security of our service or security of our data, while security in the private network might actually mean safety. And how does the AI know to define, to make a decision which is the right optimal decision on the network for those two types of, or those multiple types of criteria? So I think service assurance and testing is going to have to play a big role within that.
Absolutely. I mean, it seems as though the whole definition is going to, of what assurance is, or what it needs to do, is fundamentally changing then, and that sort of bedrock of the sort of roles and responsibilities that you might be faced with. I mean, to some degree, it sounds as though maybe um, assurance is starting to tie in increasingly with orchestration and that sort of performance management thing. I mean, is that fair? I don't know sort of what the plans are for Spirent.
I think it is. I think it already has. We're sort of already doing that today within sort of the 5G sphere in terms of that traditional sort of maybe silo approach where testing, fulfillment, and assurance were all sort of individual areas. They're now all part of, I would say, the same orchestration environment where you're needing to, because you're having continuous changes, updates always on the network, you need to be able to continuously revalidate them. You need to be able to continuously monitor them, the efficacy of them. And you need to be able to form the orchestrator, feedback that to the orchestrator to create sort of more closed loop processes to allow the network to self-manage. And you're starting to see that, as I said today, we've got a number of clients and customers already who are doing this. They're taking sort of that process where they're building continuous test and monitoring into how they actually manage the early 5G networks. We're already starting to see a number of other customers already starting to explore a new 5G function called the NWDAF, which is the network's data analytic functions. In essence, it's really an early form of AI in the network, which can then, in essence, create recommendations to the orchestrators to recommend that they should make these changes. And in that environment, where Spirent's working is that we're doing sort of two roles here. We're helping seed the NWDAF to make sure it's got a solid set of information to make these predictions on. And we're able to do that because we're actively testing the network all the time. So we're injecting synthetic traffic into the network, and then the feedback becomes a data set, a single point of truth data set that starts feeding the AI intelligence. The secondary side of it then is when the NWDAF does make those recommendations and the orchestrator makes a decision to do it, we can sort of rapidly retest that and say, yeah, that's actually going to preserve the performance, or the capacity increase is going to work. And that allows then the orchestrator to actually be confident to maintain the change or potentially do a fast rollback. And that's important because that concept of fast failing is actually, again, it's sort of a cloud native IT principle where you can make rapid iterative changes. And if they don't work, you can roll back sort of really rapidly and you don't really impact any quality of service or performance. And that's where we're going to see that, gradually that's going to build itself out, broader within our networks, but it's already happening today.
Cool. I mean, some people are starting to talk about the idea of user-centric networks, and I think that sort of speaks to some of the things you've mentioned around the idea of mesh networking and so on. Essentially, allowing the available resources to flex to fit what the user's demanding, rather than saying, this is the network capacity, take it or leave it. But at the same time, there are always going to be some areas that are constrained, no matter what, particularly where you've got high volumes of users. So I don't know if you've been sort of having those kinds of conversations about how to sort of resolve those issues and how that ties into this whole sort of question of governance or assurance, and whether that plays creates problems, I guess, for the telcos who are looking at this as a potential revenue generator.
Yeah, I mean, I would say there's a lot of baby steps at the moment in terms of looking at multiple sort of technology pathways that need to probably come together to truly enable it. You are seeing areas like convergence at the access layer, where you could potentially combine things like 5G and Wi-Fi as a more converged use case. So you could actually have methodologies where you're actually simultaneously connected to both at the same time, where you could then make intelligent decisions that I potentially move traffic to one for a resilient use case, say, or there's too much capacity on the 5G network, or simply for a policy decision. And we're seeing quite a lot of interest in testing around that, specifically even in private or campus network environments, where there's a lot of demand for resilience of connectivity for mission critical types of applications. You then have it from the network side and network resource side, and you're seeing a combination here, Alex, of how do we use network slicing to probably offer sort of differentiated or quality of services to some of those single consumers, married also then with the cloud architectures as well, specifically the edge architectures, where that you can sort of couple together the availability to spin more capacity up more at the edge locations. So, okay, you can't necessarily solve a radio dynamic all the time if radio resources are constrained. But if the next bottleneck is potentially the sort of the processing part, which in many cases it is, then you have that availability to actually then dynamically use cloud resources at the edge to give more potential processing, more memory allocated to that. So a lot of I would say what we're seeing in early trials at the moment is trying to combine a lot of these tech capabilities together. I mean, a good example of this was we had a demonstration this year at Barcelona with IBM and Palo Alto Networks, where we were trying to demonstrating with them how they could dynamically spin up lots of different types of network slices to provide both performance and security towards enterprise applications. And what was quite interesting of this is that they wanted to be able to validate, first of all, that you could guarantee the performance of these slices under lots of different conditions, lots of different environmental conditions where there potentially was going to be constraints on resources. But what the enterprises were additionally is interested in is that could you also guarantee the security during all of these? Because what would happen if resources were being constrained because there was an attack going on the network and it was consuming a load of resource? Would that impact performance? Would it also impact on the security efficacy? So we were looking at ways of how you could actually not only set this up, but then continuously test and validate that the performance was being met, the efficacy of the security was still fit for purpose in essence. And I think we're starting to see quite a lot of positive results coming out of that these types of capabilities are applicable today. I mean, there's still a lot of work to be done, but I think you're going to see more and more of these probably starting to creep into some of the operator business case use cases that they're going to start to monetize probably in the next sort of 12 months.